Hi all. So today we are moving to our section 2. So in the last section we have discussed about the properties of matrices and some basic idea of matrices, and also we have looked some basic definition of vectors. So in this video we are looking what is a linear system, and also how to solve a linear system by using Gaussian elimination method. So we have many methods to solve, but in this video we are discussing how to solve a linear system with Gaussian elimination method. So first of all, let us discuss what is a linear equation. So as you all know that from the name itself, you can know that what linear means line, right? So when we are drawing that equation in a graph, when we are substituting that and when we are drawing the graph of this equation, we will get a straight line. That is, the highest power of the variable is 1. So here you can see the definition. How can you define a linear equation? Linear equations can be in any variable. So here there are two variables, as you can see, x and y are the variables, and you have numbers. It's an equation, so you will have equal to sign. So here we have a linear equation in two variables, and the second one is also an example of linear equation in two variables. So the main thing you have to understand is the highest power. If the highest power of equation is 1, all variable highest power is 1, we can say that it is a linear equation, and you can see it is actually a line. When we plot this graph, we will get a line. So in this chapter, we are mainly discussing about the system of linear equation in three variables. So you can see there will be three variables, x, y, and z are the variables, and you will have numbers or constants, a1, a2, c1, d1, like that. And here you will have, as there is three variables, you will get three equations. If there are two variables, you will get two equations. The system of linear equation contains two type of equation, and here it is three variable equation. So you will have three equations. So this system, this set is called the system of linear equation in three variables. So in this module we are discussing how to solve this type, or how to find the value of x, y, z which satisfy this three condition. Okay, so we are moving to the next slide. So first method we are going to study is Gaussian elimination method. So it is one of the simplest and easiest method. And the thing is, we use metrics to solve. We convert the linear equation into variables, system of linear equation to variables into a matrix, and then we do that. Like that, we are doing the process. So first method is Gaussian elimination method, an algorithmic approach to solving linear system. So what is it? Gaussian elimination is a systematic algorithm used in linear algebra to solve system of linear equation. It transforms a complex system into a simplified triangular form. And why we are using it? It is more efficient than substitution or Cramer's rule, which I think you have already studied for large system. It serves as the foundation for metric inversion and calculating determinants in computer algorithms. So why we are using it is it is considered as one of the efficient and most easy, because it's very easy to solve. At least for some system of linear equation, it is easy to solve. So that's why we are mainly using Gaussian elimination method to solve a system of linear equation. And here are some steps to do Gaussian elimination. So by doing a problem, you will be clear with that. But now let us check how to do the steps of Gaussian elimination. So first thing is augmented matrix. So when you are getting a linear equation in three variables, that is here if you look, you can see here there is a linear equation in three variables. So first thing is I want to convert it to an augmented matrix. So what is an augmented matrix? To solve a system efficiently, we detach the coefficients from the variables and store them in an augmented matrix. Each row represents an equation. So you can see each row, 1, 2, 3. We will have three rows. Each column represents a variable x, y, z. The vertical line represents the equal sign. So here you can see So I am taking the first equation a1x plus b1y plus c1z equal to d1. So I am writing the coefficients in the rows. That's called each row equation is an equation. So that is a1. Writing the coefficient of x in a1, coefficient of y b1 and coefficient of z z1, and equal to symbol is represented with this vertical line. Okay, so instead of equal to, we will represent this by this one, and this is equal to d1. And the second equation is also written as like this, and the third equation will be also written like this. So we will get a matrix, and this type of matrix, this converted matrix, is called an augmented matrix. So the first step we do to do a Gaussian elimination is to first write this equation in an augmented matrix form. So the second thing is row equivalent form. So what is row equivalent form? Before knowing that, we should know what are the three operations we can do in a rows. So the first one is swap. Swap means we can swap the equation if we need it. And the second one is add a multiple of one row to another row to create a zero. So we can add or multiply the numbers to we can actually multiply constants to the rows, and we can also add this corresponding rows, that we can add row 1 and row 2, or we can add row 2 and row 3, like that. The multiple a row by any non-zero constant, that is the thing. We can multiply row with a constant 2 or 3 or like that. We can take any number and we can multiply with that. So by doing this by doing this row operations, we will convert this augmented matrix to a row equivalent form. So this is the form. We will convert this augmented matrix by using row operations. We will do some operations and we will convert this matrix, this augmented matrix, to a row equivalent form. And the third thing is back substitution. So what is that? We will substitute it back. So we have converted this equation to a matrix, and now we are converting this matrix to a equation like that. The same way, like ax, by, c is equal to d, and 0, 0x, so it is 0 itself, ey, f is equal to g, and 0, 0, you have 2, 0, and h is equal to I. Like that, we are back substituting. So the main thing you have to remember is this three steps. So first step is convert the equation into a augmented matrix, and the second is make it a row equivalent form. That is, by doing this row operations, you can convert this matrix to a row equivalent form. And next one is we are substituting it back. So that is we are making this matrix to a 3 equation. So from here you can solve for z. So here you can see z can be I by h, and by substituting this z here, we will get the value of y, and by substituting this y and z in the third, that is actually this is the first equation. In the first equation, we will get the value of x. Like that, we will find the value. We will solve for x, y, and z. We will find the value of x, y, and z. Okay. So we can do a problem. I'm going to discuss two problems here. So the first problem is solve the system of linear equation by using Gaussian elimination. So we have a system of linear equation, and we are going to solve this by using Gaussian elimination method. So as you say that the first step is, what is the first step? To convert this linear equation into a augmented matrix. So that is the initial state. So this is the linear equation in 3 variables we got, and we are directly converting that into a augmented matrix. So how can we do that? The similar way, that is 2x plus 3y minus z equal to 5. So we are taking only the coefficients of this variable. That is, what is the coefficient of x? It is 2. So I am writing the first element as 2. And the second element is 3. That is, coefficient of y is 3. I am writing the 3 here. And z is minus 1. And I am writing minus 1 here. And after, instead of equal to, I am drawing a vertical line. And the next thing we have to write is the number here. So I'm writing that 5 here. Like in similar way, we are writing these two equations as rows of this matrix. That is, coefficients are 4, 1, 2, 6. Similarly, here we have that 4, 1, 2, 6 and minus 2, 5, 1 and we have minus 2, 5, 1 and minus 4 here. Hope you understand that. Next, we are moving to second step, that is row operation. So here is actually we are doing work here. So the thing is, we have to convert this matrix to a row equivalent matrix. That is, you can see here, this is the format we have to convert this to. That is the three elements. As you can see, we have to make it 0, 0, 0, 0 like that. So it is a lower triangular. So the thing is, we have to do row operation here. So the thing you have to remember is that for making, so I'm taking the first element 4. So I have to make this 0 by doing row operations. The only row operations is possible is we can add or subtract the corresponding rows and columns, or we can multiply. The only multiplication is possible by a constant. We can multiply constant and also we can interchange. So here there is no possible of interchange because there is no 0 elements here. So the only thing we can do is adding rows or multiplying a constant. So we want to make this 4 0. So how can I do that? So the main thing you have to understand is we are doing operations of R2 with respect to R1 only. Okay, then only we will get that. So I am doing operation with R2 and R1 and similarly R3 and R1. That is the first step. We are doing the operations with R1 itself. So I'm taking R2, I'm taking 4 and I have to make this 4 0. So what is this thing? If this is 0, this 2 is 0 means, 2 is 4 means if you subtract that we will get a 0, right? So how can I make this 2 4? So by multiplying it 2, I can make it 4 and by subtracting this 4 minus that 4, I will get a 0. So that is the first thing we have to do. That is row 2 will change to row 2 minus 2 into R1. That is, we are multiplying a 2 to this row and we are subtracting this R2 with that 2 into R. So we will get a matrix like this. So how can you do that? That is R2 and get 4. That is 4 minus 2 into 2. That is 0. Writing it 0. And 1 minus 2 into 5. That is minus 5. And 2 minus 2 into minus 1. That is, we are getting a 4 here. And 6, we are also doing it for this column also. That is 6 minus 2 into 5. So we are getting a minus 4. So similarly, we have to convert this minus 2 also to 0. So how can I make this minus 2 0? The thing is, we can simply add this 2. Okay, that is by adding R3 and R1, we will get a 0 here. So it is simple, very simple. So minus 2 plus 2, we will get a 0. 5 plus 3, we will get a 8 here. And 1 plus minus 1, again we will get a 0 here. And minus 4 plus 5, we are getting 1. And the thing is, we have to convert this element also. We have already converted this. We have to also make this 8 0. That is the row equivalent form. So we have to make this 8 also 0. So how can I make this 8 0? So if I get a 0 8 here, and if I add or subtract that, I will get a 0, right? So how can I make this minus 5 8? So I am multiplying this minus 5 into 8 by 5. So 5 will cut and you will get a 8, right? So I'm doing the operation there, that is R3. Here you can see there is a minus, so we can plus it. So R3 plus 8 by 5 into R2, we will get 0 here. And we are doing that same operations to the coming elements also. So the resulting will be, here you get 0. And the next thing you get is 0 plus 8 by 5 into 4, that is 32 by 5. And 1 plus 8 by 5 into minus 4. So you are getting a minus 27 by 5 here. So that is the row equivalent form you get. And the next step 3 is by substitution. So I'm substituting the reverse. So here it is 2x plus 3y minus z equal to 5. So the next thing is there is 0x, but 0x is not necessary to write. So I am writing minus 5y plus 4z equal to minus 4. And the next two variables are 0. Not variables are 0. The coefficients are 0. So we don't want to write that. So 32 by 5 into z equal to minus 27 by 5. That is the third equation. So you got three equations here. And I am solving it. Now it is very easy to solve because as you can see, there is no other variables here. So from here, you will directly get the value of z, right? So this is one of the easiest method because I am converting, as you can see, the system of linear equation we got was a very big one. It was very difficult to solve, but it became easier. I reduced to this level. So that we are doing by Gaussian elimination method. So here I have wrote the fourth step from equation 3. From equation 3, you will get the value of z as minus 27 by 32 because 5 will cancel and 32 cross multiplication, you will get minus 27 by 32. And by substituting this z value in the second equation, instead of z, you can substitute minus 27 by 32. You will get y value. So you will get y as 1 by 8. And in similar way, now you got y and z. So by substituting that to the first equation, you will get the value of x. So the solution is x equal to 121 by 64, y equal to 1 by 8, and z equal to minus 27 by 32 is the final result of this. So we can discuss another problem 2. Problem 2, if you look itself, you can understand. I will just briefly explain that. So the question is solve the system of linear equation by the Gaussian elimination. So it is a similar linear equation. So the first step is we have to convert this to a augmented matrix. That is the initial state. So you can see I have converted. I have took only the coefficient 2x plus y minus z equal to 8. And I have write 2, 1, minus 1, 8, and minus 3, minus 1, 2, minus 11, minus 2, 1, 2, minus 3. So for making this 2, 0, I am multiplying with 4 here. So 4 into 1 by 2, you will get a 2 itself. And by subtracting the R3 minus 4 R2, you will get 0 here. And similarly by doing this, you will get minus 1, 1. So like that you got the row equivalent form. And the next is step 3. We are substituting it back. So I'm getting a equation like this. 2x plus y minus z equal to a. 1 by 2 y, 1 by 2 is equal to 1. Then minus 1 is equal to 1. So from here itself, I will get the value of z as minus 1. By substituting this z to y, z to the second equation, I get y equal to 3 and x equal to 2. So like that, we solve this x equal to 2, y equal to 3, and z equal to minus 1. So just remember the step. We have only 3 steps. So the first step is augmented matrix. Second one is making it row equivalent form by using row operations. And the third step is we are reversing the substitution. Okay, we are substituting that. Like that, by solving this, we will get the solution. Okay, so we can end this section here. Thank you for listening.